Yes, children. Now, this is a fourth video of chapter 2, chapter name acid, base and salt. Now, first review of first 3 video. Now, in this chapter we have covered classification of acid, base and salt, and to test acid and bases by using indicators, synthetic indicator, and general properties of acid and strength of acids. Now, and activities 2.1. Today in this video we will study following the topic. Number 1, review of this video in terms of question answer. Second, general properties of bases, and then strength of bases, and then activities. Already we know this chapter contains 15 almost 15 activities and 2 group activities. We will take up one by one, right? So students, for this I am calling for question answer session. Yes, Trisha, please come.
Hello everyone. So today we are going to do the question answer session of chapter acid, bases and salts. There are 5 questions and I'm going to answer them. So first question is H3PO2 a tribasic acid? Comment. So first of all we will know that what is the basicity of H3PO2. First of all, tribasic acid means the basicity of that particular acid is 3. Now let's see what's the basicity. Now first of all, structure is H3PO2. What's the structure of H3PO2? 1, 2, 3 H and then 2 O. Okay. Over here you are able to see only one H is ionizable. Only one H is ionizable. And what do you mean by the basicity? Basicity says the number of H hydrogen ions ionizable in a particular acid or acid. So over here only one is ionizable. So the basicity will be 1. That is it is a monobasic acid. So the statement will be no. No or false, because only one H is ionizable in this particular acid. Next question is HCl acid? First of all, HCl is HCl gas acid, sorry. So first of all, HCl, when you dissolve HCl in water, it will release the hydrogen ion. So then we will be able to know that it is an acid. But over here, HCl is in the gaseous state. It is in the gaseous state, and it means that it is flowing in the air. No presence of water is there. Water is not present at that time. So when the water is not present, so when you will dissolve this HCl gas, when you will not be able to dissolve this HCl gas in water, how will you know that which ion is going to be released, OH ion or H ion? Therefore, it is neither an acid nor the base. Okay, it is neither an acid. HCl gas is neither acid nor base. It means according to this question you will only write as HCl gas is not an acid. Not an acid. Whatever is us, just you need to write that. Give an example of a hydrogen containing compound is not an acid. We may take this only, HCl gas. No, not HCl, it's HCl gas. Why? See, it isn't compound, it contains the H but isn't an acid. So it will be HCl gas. What is common in acid and base? So first of all, they all form sign. They all form ions. They release ion, H ion, OH ion. Next is, are the good conductor of electricity? Are good conductors of what? Electricity. Of electricity. Now is which color is required or which color is seen when phenolphthalein is dissolved in the basic solution? Okay. So the color will be pink. Okay, these are the 5 question answers. Thank you.
Okay. Now, after question answer session, we will start general properties of bases. See, as we heard the name of base means bitter in taste, or in everyday life we use neem, karela, right? So when we eat, their taste is bitter in taste. Okay, so these are the basic in nature. Next property is very important, that is slippery or soapy in nature. Soapy in nature, this is the second property of bases. Third very important property is also as like acids so corrosive in nature, similar bases also so corrosive in nature. The corrosive means burning sensation on living cells or very harmful to our cells, right? Now next properties is action on different indicators on basic solution. The point is number 1, right? So if we'll take a base in 3 container, right? So C is here 1, 2, 3 container, A, B, C. In these 3 container, basic solution is containing. Any basic solution is present in these 3 container. Now litmus red. Litmus, add 1 or 2 drop of litmus red solution in basic solution. So what would happen? This red will turn into the blue. So it indicates this is a basic solution. Now next, if we add phenolphthalein, 1 or 2 drops in basic solution, color pink. Pink color appears. So it indicates yes, basic solution. Now next, methyl orange. Methyl orange in drop in basic solution, same, it gives yellow color. So this is a 4th property, action of natural indicator on of basic solutions. Now next property is when metal, or we would say कि base reacts with acid. See, this is property, chemical equations. Base we will take NaOH, acid, sulfuric acid and C. So here is stoichiometric chemical equation, sodium sulfate, salt and sea water. This is a salt plus water and it is acid and it is weight. So this is also neutralization reactions. Normally neutralization reaction is exothermic in nature. So this is a one property. Next property with chemical equation, when metal like zinc, granulated zinc is reacts with NaOH, zinc, Na2, sodium zincate plus hydrogen gas evolved. Now see children, this is NaOH, 2 mole, sodium zincate, this is sodium zincate. Now another reaction we will take 2 aluminium, NaOH, base and water. See, take 2 mole, it will form sodium meta aluminate plus how many hydrogen is here? 2, 2, 4, 6. So 3 mole of hydrogen. So in this case, hydrogen gas is evolving. Now, question, this hydrogen gas is evolving. Now, if we bring a burning candle, so what would happen? It will produce pop sound. It will produce pop sound. Clear? So this is the indication of presence of hydrogen. Now next reaction property is when base reacts with non-metallic oxide. So question is base calcium hydroxide, carbon dioxide. Carbon dioxide, sulfur dioxide, these are non-metallic oxide. So very popular reaction it is. So it will form CO3 and water. This is the milkiness. Clear? So this is the next reactions with this. Next property is this way, very important, conduction of electricity. So there's a common in this, when acid dissolve in solution water, they furnish ions. Similarly, bases dissolve in water, furnace ion, OH ion, right? Acid and bases, according to the Anilesh equation. Anilesh equation, he put forward this theory in 1884, right? So this is a definite according to the acid bases, according to the Anilesh. Now here in this, next is ions. So point is, acid dissolve in water or base dissolve in water, both furnish ion, both produce ion, and ion product is a fundamental property to show conduction of electricity. So conduction of electricity is a common property is seen in acid or on bases. See, after this, in properties, topic comes strength. Strength of bases. As we have studied in acids, same factor. When any basis is completely dissociated into the ions, completely means very close to 99.9% dissociation into a, so this is a property of strong acid and represented by alpha value. So earlier we told you alpha is equal to 1, strong acid, alpha is less than 1, weak acid. Here this is a quality, property. So strength of bases, the concept is same in acid. Now NaOH, KOH, in water they produce ions like this. Similarly KOH, they produce ions. So they are strong acid. Now NH4OH, weak acid, it takes more time, uncompletely dissociated ions, that is why weak acid. Aluminum hydroxide, same, they are all weak acid. Clear? So student, this is the one. Now one more important characteristics of sodium hydroxide and potassium hydroxide, that is deliquescent in nature, right? What is the meaning of deliquescent in nature? Deliquescent means moisture absorber. Moisture absorber. So when we keep these chemicals in moisture, they will absorb and they will lose their strength, right? Turn into the liquid, right? So this is the quality is of this property of deliquescent in nature. Now next quality, same as we do in the dilution, same base, strong base dilution, same process. They also the exothermic, when sodium hydroxide solids, pellets of sodium hydroxide is dissolved in water. Exothermic, you will see beaker, you will feel heat, hot. Why? Same exothermic reaction takes place. So in case of dilution of strong bases. Okay. Now next, after this, we will discuss property that is next. Same as we do study with neutralization reaction, when acid plus base, salt neutralization reaction. Then after this we will start work in with activities. Clear? So activities session. Activities. Now in previous video we have covered activity 2.1, right? In this video we will take up 2.2. So aim. Here I'm not going to in details to cover the entire activity. We will take up the key discussion and key point, conclusion of each activity. Okay? So aim of this activity is very simple: to test acid and base by using olfactory indicators. Acid base by using olfactory indicator. Simple. Here I am taking example. They are very popular. Vanilla flavor, onion, and clove oil, vinegar solution. These are the chemical substance. Now, if you see a vanilla flavor through the diffusion technique, our nose can identify, yes, this is a flavor of vanilla. You know why? Because there's a nerve is known as, it has connection with the nose to our brain. That nerve is known as olfactory nerve. So that is why our nose is known as olfactory indicators. So what is acid-base indicator? Very simple, a chemical substance which gives one color or odor in one medium or other color in different medium, right? So this is known as acid-base indicators, or olfactory indicator is one of them. So this is one. So through the nose we can detect. So this is a, when you will see the vanilla, onion, clove oil, vinegar, our nose can detect, yes, this type vanilla flavor is coming, acid vinegar smell is there, and onion smell is there. If in our life, suppose if you have used onion, right, then when you go come across somebody, they will come judge you through the smell. Yes, you have taken onion, so we can judge by through the smell, olfactory nerve. You have used in your diet or salad onion. Now next, so this is so conclusion point is this, olfactory nerves. Now next activity is very important that we will take. Activity is activity 2.3. Aim of this, to study of the reaction metal reacts with base. This is activity. Metal reacts with weight. This reaction is not a new for us. Already we have studied in many places in previous what would happen when zinc reacts with NaOH. Here is very granulated zinc reacts with NaOH, sodium zincate plus hydrogen gas. Now in this question, what is here? When this gas is passed in soap solution, suppose there is a soap solution. When this gas is passed in soap solution, what would happen? Some type of gas is coming out, like this, in bubbles is coming. So bubble is coming due to coming in upward direction, some type of gas. It indicates gas, but how do you confirm which kind of gas it is? That is, we can judge through, suppose gas is coming in upward direction, so we can use a candle, any fire, or suppose let me take the candle. If we candle bring in the contact of hydrogen, so hydrogen, the property of hydrogen is highly inflammable in nature. It catches fire very easily and it produces pop sound. So many questions may be generated like this. Which type of gas, right? How do you detect it is a hydrogen? Through this test we can detect the hydrogen. Clear? So this is all about the conclusion, the point. They are very important. So children, the activity 2.3. So at this level information is okay now. Now let's we take up activity 2.4. Activity 2.4, what it says, activity 2.4. Now when any metal or carbonates, bicarbonates, any to study metal carbonates or bicarbonates, or bicarbonates with metal carbonate or bicarbonate reacts with acid. So this is the aim, to study when metal carbonate or bicarbonate reacts with acid. See, metal carbonate, this is a test tube A, this is test tube B. Now take 0.5 gram sodium carbonate or sodium bicarbonate, same amount, right? And add in this HCl, add HCl. So according to this activity, what do you observe? So already we know the reaction already we have studied. The reaction of sodium carbonate reacts with HCl, sodium bicarbonate reacts with HCl. You know. So here's a common point, conclusion point. Any carbonate or bicarbonate salt reacts with acid, it produces corresponding salt plus carbon dioxide and water. Okay, keep in this same point in your mind. Okay, all carbonates or bicarbonate salts, when they react with acid, they produce corresponding salts, water and carbon dioxide. See, so carbon dioxide evaporation, it comes fizzing out a brisk effervescence, very popular, brisk effervescence due to evaporation of carbon dioxide gas. Now what would happen is when this carbon dioxide reacts with lime water, it turns milky. Already we have studied. So see this is all about CO2 reacts with carbon dioxide, lime water, it turns calcium carbonate plus water milkiness, and this milkiness, when this reacts, add more CO2 gas, so it will form calcium bicarbonate. Means milkiness will disappear. Clear? So student, question may arises like this. Clear? So is this way, conclusion point is very important. All metal carbonates or bicarbonates, when they do react with acids, they form corresponding salts, water and CO2. CO2 passes like water, turns milky, and further it treats with excess CO2. This milkiness will disappear due to formation of calcium bicarbonate. This is the point. So is this way, activity 2.5 we have covered, 2.2, 2.3, 2.4, 2.5 all about. Or you can perform these activities in your chemical laboratory in your school also. Clear? So that you will be permanent remembrance. Clear? You can understand very well through the practical application of these reactions or especially perform in the laboratory. Clear? So is this way, in this chapter again I am recapping general properties of bases, strength of bases, dilution form, and specific nature of means deliquescent nature of sodium hydroxide and potassium hydroxide. So children, I am just today's in this video we are just winding up. Till then, bye, and next video we will cover strength. How would you predict nature of solution, acidic, basic or neutral? So through the pH value or universal indicator in next video. Till then student, okay, thank you children.